How are you everybody? How are you today? This is the 8th lecture in econometrics course for 4th year statistic English section beginners. And in this lecture we will continue our speaking about multiple linear regression model and ordinary least square method and the properties about ordinary least square method. This is a very important lecture related to multiple linear regression speaking. Multiple linear regression model part 4. We will continue our speaking about multiple linear regression model and ordinary least square method and the properties of ordinary least square method. In this part 4, by continuing speaking about what is the properties of ordinary least square method and what is the advantage of ordinary least square method, it's very important lecture about ordinary least square method, and I want from every student to study this lecture very closely. Properties of ordinary least square estimator. Estimation error. The estimation error of P is P minus beta equal x dash x inverse x dash y minus beta equal x dash x inverse x dash x beta plus epsilon minus beta. The final result x dash x inverse x dash epsilon. This is the first estimation error. Number 2, bias. The biasness. Since x is assumed to be non-stochastic and expected epsilon is 0, expected b minus beta equal x dash x inverse x dash expected epsilon equals 0. This is very important. Thus, ordinary least square is an unbiased estimator of beta, so that it is a very good estimation, very good estimator of the parameter coefficient in the multiple linear regression or linear regression model, because this is an unbiased estimator. The unbiased estimator is the very best estimator for the coefficient of beta. Covariance matrix. The covariance matrix of B is vector P equal VP, variance of B equal expected B minus beta, B minus beta dash multiplied by B minus beta dash equal expected x dash x inverse x dash epsilon epsilon dash x dash x inverse x dash x inverse x dash expected epsilon epsilon dash x dash x inverse equal sigma square x dash x inverse x dash identity matrix x dash x inverse sigma square x dash x inverse. This is a variance. The variance of P can be obtained as the sum of variance of all B1, B2 and B2k, which in the trace of covariance matrix of B, thus variance B equal to VB summation expected B minus BI to the power square summation variance BI from I from 1 to k. Estimation of sigma square. The least square criterion cannot be used to estimate sigma square, because sigma square does not appear in S beta, since expected epsilon I square equals sigma square, so we attempt with residual E epsilon I to estimate sigma square as follows. Error equal y minus y hat, it's obviously equal y minus x. These all matrices x dash x inverse x dash y, so that the result is to bar y. Consider the residual of sum of square. Residual sum of square equal y bar h y dash h bar y. Also, sum of square residual equal y dash y minus b dash x dash y, using x dash xb equal x dash y. It's very important about estimation about sigma square and the mathematical induction. Sum of square residual x y dash x bar y equal in the final epsilon bar h epsilon dash h bar epsilon using h dash x equal 0. Hat matrix. Since epsilon distributed normally 0 sigma square, so y must be distributed normally x beta and sigma square I. Hence y dash h bar y distributed chi square n minus k. Thus, expected y dash h bar y equal n minus k sigma square or expected this y dash h bar y over n minus k sigma square, or expected mean square residual equal x sigma square, where mean residual equals sum of residual over n minus k is the mean sum of squares due to residual. Thus an unbiased estimator of sigma square is sigma square hat equal mean square residual equals s square c, which is a model dependent estimator. Variance of y hat, the variance of y hat is vy hat equal vxb equal xvb x dash equal sigma square x dash x inverse x dash equal sigma square in h the hat matrix. This is the variance of y hat and the ending of our lecture. Thank you for everybody. See you in the next lecture in the faculty and on the faculty website. Thank you for everybody.